Are you see the presentation now?
Yes, we can see the presentation. Kindly toggle to slideshow and then continue.
Okay. First, I'm very happy to share this research and this great event. I'm Mohamed Youssef. Um, uh, a master student degree. I'm teaching assistant in the Faculty of Renewable Energy Engineering at the University for Sustainable Development in Egypt. I will present solar energy enhancing electroregulation for sustainable water purification with machine learning and Internet of Things. Water security is a global issue. If we see 40% of the global population is affected by water scarcity, which can lead to water stress, food insecurity, and socioeconomic challenge. In Egypt, we need 54 billion cubic meter to reach the minimum level of water safety. So we spent $3.2 billion annually to produce 12 billion cubic meter of fresh water from desalination process. At the same time, in agriculture sector in Egypt consumes 86% from Egypt fresh water annually. At the same time, the wastewater in agriculture sector in Egypt is 3 billion cubic meter annually. It's not a water waste. It caused carbon emission. Approximately 6% of Egypt carbon emission is reduced from agriculture wastewater. To mitigate this challenge, our research focus on applying the electroregulation and enhance the performance of this process to purify and treatment the agriculture wastewater. Through this research and using Internet of Things technology to control the time factor and the ratio of salts and minerals for using water in industrial, agriculture, and light personal purpose. We have succeeded in reusing 95% of various types of agriculture wastewater with an removal efficiency ranging from 92% to 97%. So the electroregulation is a combination between electro analysis and chemical analysis, specifically high and light chemical analysis in this process. By sequential and optimization of this process, we treatment the water during from 7 to 8 minutes for one process. So from this standpoint, why we encourage the electroregulation and why we research to enhance the performance of electroregulation. Let me tell you the advantage of electroregulation with IoT and machine learning. I mean the smart controlling and smart connection by mobile app. The electroregulation process offers several advantages, including high removal efficiency ranging between 92% to 97% in organic wastewater specifically. Cost effectiveness estimated between 12 to 16 cents per ton of wastewater. Minimal chemical usage by smart calibrating the quantity of water. It's very, very important thing to make calibration the quantity of the water and pollutant that exists in the water to perform and to set the time for every process, reducing the time requirement to achieve the purification rates we have reached by 30% decreasing. So I said the process take a time from 6 to 8 minutes. In practical work, unit design by integration between solar thermal technology as a power source and the electrification unit. First step, we get the water from solar thermal technology. But after cooling the PV systems, we get a temperature ranging between 45 and 55 Celsius to facilitate the sedimentation process. And then we make the process, the first process of sedimentation for separation in minerals and heavy waste from water beings in the first stage. Next stage, we make a flotation process to separate the light water waste and light minerals about the water. Then we move to the last stage to control in solid and minerals by using machine learning to specific and to set the specific purpose and what I want to use this treatment. So the ratio of minerals and salts difference due to the purpose of use treatment water. So we can optimize this process by set a parameter. We have 6 important parameters. The first is pH of the wastewater, the electrolytic concentration, and the type of electrodes material that we used. The distance between the electrodes is very important thing, the amount of current or current density that we will use in the unit, and last the electrolysis time. So from this standpoint, we create this integrated unit between solar energy and the electrification process by using machine learning and IoT to control the time factor, because if we can control the time factor, we can get the difference amount of treatment fresh water. At the same time, we raised the efficiency of solar panel to 35% instead of 22. This is the prototype and experimental lab. And then we see in this picture the difference between water before treatment process and after treatment process. Concluding, this project aims to evaluate the efficiency of electroregulation process to decreasing the amount of agriculture wastewater and then decreasing the amount of carbon emission from agriculture wastewater, and the effective cost of this process comparison with the desalination process. The finding of this research will contribute to the development of sustainable water management strategies in Egypt specifically and globally, and provide insights into the broader global water security challenge. By exploring innovative technology like electrification and solar thermal technology, we can pave the way for efficient and environmentally responsible solution to address water scarcity, reduce carbon emission, and promote the sustainable use of water resource worldwide. The project outcome under SDGs, third SDGs, good health and well-being, by avoid disease caused by sewage wastewater or agriculture wastewater, clean water and sanitation by reuse of agriculture drains wastewater and treated municipal wastewater, and get affordable and clean energy by operating of solar energy efficiency by 33 or to 35%. The decent work and economic growth by cost-effective method estimated between 12 and 16 cents per ton of wastewater, as I said the previously slides. Industry, innovative, and infrastructure by creating a unit with 80% local manufactured with Egyptian products available in the local market and using of remote control technology and artificial intelligence. It's machine learning. Reach the proof and achieve the proof of sustainable cities and communities by reducing carbon footprint resulting from cities and climate action by reducing the environmental pollution rates resulting from sewage wastewater for drinking water and contributing to solve the problem of climate change. My team and other researchers that work on this research, Youssef Yahya and Manar Tahir and me, Mohamed Youssef. Thank you.
Thank you very much.